Hey there, thanks for checking in today. I'm so excited to show you one of my favorite methods for teaching kids how to multiply big numbers. As numbers get bigger, there's more to organize, and that's where a lot of kids have trouble with the traditional way that many of us learned in school. So it's just a different way of approaching the same type of math, but it gives me a different option of getting to that answer. So this method is called the area method, and we set it up like this. So if I have a multiplication problem like 45 times 19, my first step to solving this problem is to draw a box. Then we write these numbers in what's called expanded form. So that means we're going to write them by what they're worth in each place value. So this 4 isn't actually worth 4, it's worth 40. So I'm going to write the number 40. This one's worth 5. I'm going to write 5 with a space in between them. For 19, I'm going to do the same thing, but I'm going to go on the other side of the box. So 19, well, that 1 is actually worth 10. It's in the tens place. And that 9 is worth 9 ones. I'm going to write 9 ones. Next, I'm going to split these up into columns like this. So it's basically, it looks like a window, and that's actually what I'll refer to it as when I'm first teaching my students, because it's a very common looking window to what they might actually draw in art class. So now what we're going to do is multiply going across. So I'm going to multiply 10 times the two top numbers. So instead of saying 10 times 40, a lot of kids would look at those giant numbers and go, wow, that's tricky. I would just tell them to focus on the 1 and the 4. 1 times 4 is 4, and then we're working with zeros. We love zeros because we can just count them up. There's 2 zeros in this problem. 1, 2. So I'm going to put my 2 zeros on. 10 times 40 is 400. Next, we're going to do 10 times 5. Again, 1 times 5 is 5. There's 1 0 in this problem. 10 times 5 is 50. 9 times 4 is 36. Notice I'm just focusing on the whole digit numbers and kind of ignoring those zeros until the last part. There's 1 0 in this problem. So 9 times 40 is 360. And then the next one, 9 times 5 is 45. Okay, so now once I've filled in all of my windows, my next step is to add everything together that is in those windows. So 400 plus 360, I can do that in my head. It's 760. If your kiddo's having a hard time doing that in their head, it's perfectly okay for them to also list out those numbers. I'm also checking off as I use something so that I know that I've already added it. As windows get bigger and we're multiplying even bigger numbers, that's really important for organization. So then next we're going to add in the 50. Doesn't really matter what order, that's just what I'm choosing to go with next. 0 plus 0 is 0. 6 plus 5 is 11. 1 plus 7 is 8. Okay, and then my final number that I need to add in is 45 plus 45. 0 plus 5 is 5. 1 plus 4 is 5. And 8 plus nothing is 855. So the answer to 45 times 19 is 855. I'm going to do it one more time just to show you again and go through those steps. I'm going to do it this time with a slightly bigger number to show you how it can be adapted to really any size number. Alright, so for this one, we'll do let's do 217 times 816. Okay, so again, I'm going to do a box, but you notice I'm working with bigger numbers, so I'm just going to adapt to that and make sure I have a bigger box. Give myself a little more room. Okay. So now my next step is to write these numbers in expanded form. So 217, this is worth 200. The 1 is worth 10, it's in my tens place. The 7 is still worth 1s because it's in my 1s place. 816 in expanded form, so 8 is worth 800. It's in my hundreds place. The 1 is worth 10 again. And the 6 is worth 6 ones. So I'm just writing them according to the place value they are in. And then each number gets its own box, basically. So it looks like this. Okay. Now I'm just going to go across and multiply. Kids kind of, as it gets bigger, sometimes they'll get confused what numbers they're multiplying for which box. So I just tell them to pay attention to one row at a time. So I'm looking across 800, and I'm going to multiply that 800 by each number in that row. Then I'll just look at my 10, and then I'll look at my 6. So again, just focusing in on the numbers that aren't zeros will really help kids when the number's big in this problem. So 8 times 2 is actually what I would say to the kids here, and they would get 16. And then how many zeros are there? Well, there's 1, 2, 3, 4. So we're going to write the 4 zeros. And it looks like I'm going to run out of room a little bit. 1, 2, 3. So 160,000. The next one, 8 times 1 is 8. And we have 3 zeros. The next one, 8 times 7 is 56 with 2 zeros. So actually it's 5,600. 2 times 1 is 2 with 3 zeros. So now I'm going right across here. 1 times 1 is 1, 2 zeros. So 10 times 10 would be 100. 1 times 7 is 7, 1 0, 70. 6 times 2 is 12. There are 2 zeros in the problem. 1,200. 6 times 10 is 60. So 6 and 1 0. 6 times 7 is 42. So now that I have all of these, it's where it gets tricky. I need to add them all together. So I'm going to go across and figure out, are there any I can group easily in my head right away to simplify this a little bit? So I could do 160,000 plus 8,000. Those are really easy numbers to work with in my head. 160,000 plus 8,000 is 168,000. The next one that I could go with that nicely is another 2,000. So 168,000 plus 2,000, 170,000. And then I'm going to come over here because it adds in nicely. 170,000, 175,600, 175,700. So 175,700 I am up to. So now I just need to add in these other ones. If they need to add everyone individually, that's fine, if that's where they are developmentally. As kids get stronger with their number sense, they can start grouping numbers like I just did. So now we have plus 1,200, 0, 0, 9, 6, 7, 1. Plus, I'm going to check off that I use that. Let's do plus 70. 0, 7, 9, 6, 7, 1. Okay. 100, we're at 176,970 plus 60, 0, 13, 10, 7, 7, 1. Okay, and then plus the 42. 2, 7, 0, 7, 7, 1. So 177,072. 177,072. As you can see from this, it gets really busy the bigger the numbers get, but it wouldn't let you shy you away from this method. It's good for kids to be able to do it this way and other ways. And sometimes what I found in my classroom is that once the kids could really do it this way, especially with the simplicity of a 2-digit problem like this one, then eventually they were able to carry it back over to that more traditional method of multi-digit multiplication that many of us parents learned while we were in school. But this way is just easier for them to organize and follow, and it also helps really build their number sense because they're working with the values of these digits rather than just it all seeming a little more random to them. Another great strategy to solve this kind of math problem is called the lattice method, which I will have a link to in my blog and another video explaining how to do that. So thanks for checking out Ellie's Teacher Mom. Make sure you let me know what else you'd like some help with or would love strategies for so I can make some more videos for you. And we'll see you back soon. Subscribe to the channel.